Hello friends, I am Babu. So today we are going to discuss about organic chemistry. Here, so we go through, this is the first video of organic chemistry. We go from basics. So don't worry, we have to tell starting from basics. So first of all, general organic chemistry. From general organic chemistry, you know double bond, single bonds, triple bond, you know that. So this is, listen, for single bond, this is sigma bond. One sigma bond will be there. If double bond is there, first we have to take one sigma bond, then only we have to go for pi bonds. Okay, this is one sigma bond. Another one is, remaining one is pi bond. Okay, done. Triple bond is there. First one you have to take one sigma bond, remaining two are pi bonds. So listen and go for one molecule. We have to take one example molecule. This is tetracyanometane. Tetra means four cyanogens will be there. Two cyanogens will be there. Ethene, you know, ethene, double bond will be there. So we have to calculate here. Now tell me here, how many pi bonds will be there? One sigma, one pi bond. Here, one sigma, two pi bonds. One sigma, two pi bonds. One sigma, two pi bonds. Here, one sigma, two pi bonds. Here also, one sigma, two bonds. Tell me total how many sigma bonds will be there? Here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma bonds will be there. Pi bonds, tell me. Here 2 2s are 4. 4, 8. 8 and 1. How much? 9. 9 pi bonds will be there. Understand? This is one example. I will tell you another examples. Okay, coming to this, some compounds are given. We have to remember. First one, tell me, this is called benzene nitrile. This is called benzene nitrile. This is another compound. It is, don't worry. Okay, this is 2. This is third compound. This is fourth compound we have given. So this is, tell me, this is called benzene nitrile. Benzene nitrile. Tell me how many hydrogens are there. It's this called how many sigma bonds. We have to find out how many sigma bonds, how many pi bonds will be there. We have to find out. So first of all, you have to imagine here one hydrogen will be there. Why hydrogen will be there? Carbon has only 3 bonds. 1, 2, 3, 4. Okay, here also 1, 2, 3, 4. 4 bonds. So by attaching hydrogen, we can satisfy the carbon valency. So each carbon has one hydrogen. One bond will means what? One sigma bond will be there. So real, listen, how many sigma bonds will be? Listen, sigma bond means, I already told you, one double bond has one sigma bond. Triple bond has one sigma bond. Everywhere one sigma bond will be there. So listen, 1, 2, 3, 4, 5, 6. 6 over. 6 sigma bonds. 7, 8, 9. 9 is over. Here 9, 10. 10 is there 10? 10 or another one? Any is there? Listen, 1, 2, 3, 4, 5, 6. 6 are there. 6, 7, 8, 9, 10, 11, 12. 12 and 13. 13 sigma bonds will be there. Tell me sigma bonds how many? 30 bonds. So come to the pi bonds. One double bond has one sigma. Triple bond also has one sigma. Tell me 1, 2, 3, 4. Pi bonds how many? 1, 2, 3, 4, 5. 5 pi bonds will be there. Pi bonds, tell me how many? 5. Understand? Next, coming to this compound. Now tell me sigma bonds how many are there? 1 will be there. Here 1 will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 over. 16, these 3 hydrogens will attach single attach. 16 plus 3, 19. 19 plus 3, 22. 22 plus 3, 25 is there, na? 25. Is it correct? Is it another time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 19, 19, 19 plus 3, how much? 22. 22 plus 3, 25. 25 is there. Is it correct? Okay, listen. Here also, this carbon has also one hydrogen. Understand? We forget and like that. Yeah. So, totally, how many sigma bond will there? 26 sigma bonds will be there. Coming to the pi bonds. Pi bonds, how many are there? 1, 2, 3. 3 will be pi bonds. 3 will be pi bonds. You are getting my point. So, these are like this we have to find out. One double bond have one sigma bond, one pi bond. Triple bond has one sigma, two pi bonds. You have to remember this much only. So, coming to the next point, next compound. Okay, here tell me pent 1, 2 diene. Diene means there. So tell me how many sigma bonds will be there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 will be sigma bond. You are getting my point. Now come to that pi bonds. 1, 2. 2 will be pi bonds. Is it correct or not? Tell me. You have to tell me. Is it correct or not? Okay. Here triple bond you have to take. That's why carbon balance na. So how many pi bonds will be there? 3 pi bonds will be there. Sorry for the convenience. 3 pi bonds will be there. This is the correct option. Okay, thank you. Next one. Hello, listen. Here what happens? So how to find out hybridization? If double bond, triple bond is given, we have to remember. Here what happens here means pi bonds. Okay, pi bonds is given. If pi bonds is given, how can you find out hybridization? We have to no. So what happens if 0 pi bonds will be there? We have to take sp3 hybridization. Why? Because if carbon has single bond, is there any double bond or triple bond? No, it is that doesn't have any double bond or triple bond. That's why it has 0 pi bond. If 0 pi bonds is there with any carbon, so it undergoes sp3 hybridization. 1 pi bond means there should be one double bond will be there. If double bond is there, we have to take that carbon as a sp2 carbon. Are you getting my point? Next one, if 2 pi bonds will be there, not sigma bonds, it's a pi bonds. So if 2 pi bonds, okay friend, next one, what happens here? Exceptions cases will be there, exception cases. So what happens exception cases? So now I told you this one, so leave it is. So here how many bonds are there? 3 bonds will be there. 3 bonds means what? Hybridization we have to get 3 bonds with 3 bonds. One carbon has 3 bonds with one free radical is there. Like this we have to get sp2 hybridization. But in this condition, here bridged atom is there, common carbon atom is there. In that cases only we have to take sp3 hybridations. So coming to the point, CF3 one radical. So if it is also 3 bonds, 3 sigma bonds, it has to be undergo sp2 hybridization. But what is condition is there? If CF3 is there, we have to take sp3 hybridization. Coming to the first, some charge species will be there, positive charge will be there, negative charge will be there. We have to consider that one. You see here what happens here means, tell me here, charge here, positive charge is there. Positive charge means how much it is sp2 hybridization. Okay, it is understand. It is radical, but when it is undergo negative charge, it means carbanion. Carbanions means 1 minus is equal to 2 electrons. 2 electrons as the minimum electrons to formation of bond. It means here 4 bonds will be there. So 4 bonds means single bonds are there. So that's why it undergoes sp3 hybridization. That's all. So we will undergo sp3 hybridization. If one case is there, if it is undergoes resonation means it undergoes conjugation. Conjugation, double bond character, like electrons will be flow like that. You know that conjugation. If conjugation or resonance will be there, if it is there, then we have to consider this carbon as a sp2 carbon. Carefully listen. If resonance is present, we have to take it as a sp2 hybridized carbon. Next coming to the concept, what happens here? Same. If listen, we have to rub it. Not about, this is about of hybridization. So some reasons will be there. So if lone pair and negative charge, is involved in resonance structures. Okay, if lone pair and negative charge involved in resonance structures, we have to consider it as pi bond. Listen carefully. So here you have to take first question. So what happens here? This CH2 double bond CH2 and single bond CH2 minus will be there. So listen carefully here. What happens here? CH2 minus. Tell me how many bonds are attached with carbon atoms. So listen, these hydrogens, not 2. These 2 hydrogen, 1 hydrogen. Total how many? 3 hydrogens. If 3 hydrogens are there, we have to get sp2 hybridization. But why? So negative charge is correct. So sp2 hybridization, sp3 hybridization. Okay, 3 and 1. Totally 4 bonds I told you. One electron, one negative charge is equal to lone pairs. It means equal to 4 bonds. Now we have to consider it as a sp3 hybridization. No, it looks like that, but here what is going there mean it is undergoing resonate conjugation structure. Conjugation structure, how it is undergoes, I will tell you. When negative charge is attached to this one, this shifted to this bond, what happens? This carbon gets 5 bonds. This carbon gets 5 bonds, but carbon valence is only 4 valence electron, 4 valence bonds. But in that case, for satisfaction of carbon, this bond will be shifted to this here. So what happens? This undergoes sp2, not sp3. Why? Because this charge has negative. Here it has, okay, it has sp2. Next one, coming to this one, what happens here? Any lone pair and negative charge are involved in resonance. Okay, so this bond is attached, this bond is shifted to here. If it is shifted, a lone pair is there. Not, we don't have any pi bond is there. So what we have to do? We have to consider lone pair as a pi bond. So we have to transfer this. One lone pair means one bond is equal to one lone pair of 2 electrons. It is correct only. So that's why it is shifted to here. It means what? Here it is undergoing conjugation. So this carbon undergoes sp2. You are getting my point. This is commonly known as furan. So all are undergoing sp2 hybridized carbon. So it is in a planar structure. If planar structure means it should be in sp2 hybridized carbon, sp2 and sp. Continuously it has to be, those atoms should be in sp2 or sp. Then only we can call it as in planar structure. Now tell me this one structure. So what happens? Bond is there, bond is shifted to like this, bond shifted to like this. This lone pair is shifted to like this. So there is a conjugation possible. So sp2 hybridized carbon will be there. Here also sp2 hybridized carbon will be there. Not here only, I am showing that place only just. This carbon has sp2 hybridization, this carbon has also sp2 hybridization, this carbon has a sp2 hybridization. Okay, next coming to this is commonly known as, this is sulfur is there now, this is oxygen is there now, this is nitrogen is there. These are called heteroatomic compounds. So different atomic inorganic elements will be attached to here. You are getting my point. So coming to this is thiophene. Commonly you have to remember names. Thiophene. If sulfur is attached to thiophene, if oxygen attached, how many rings? 1, 2, 3, 4, 5. 5-membered ring is called furan. 5-membered sulfur attached ring is called thiophene. Coming to this point, what happens here? This is called pyrrole. Pyrrole means, so here also nitrogen has one lone pair electron. It is shifted to like this, it is shifted like this, it is shifted to like this. Conjugation is possible. Conjugation is possible means it will undergo also sp2 hybridization. It will undergo sp2. It will undergo sp2 hybridization. Whatever it may be, carbon is sp2 hybridization. Okay, listen carefully. Next, we have to go through. Okay, next what happens here means, next, here examples are given. Listen, now tell me we have to undergo. This one given question. So what is this? Benzene ring is there. On benzene, negative charge will be there. If any negative charge is there, sorry, this has double bond here. Oh, this has double bond shifted to here. This bond will be shifted to here. What happens? This negative charge will be shifted to this here. So negative charge is there. It will undergo conjugation. So it will not undergo sp2 hybridization. It will undergo sp2 hybridization. I told you that. Okay, very good. Next one, sp2 hybridization is over. Next, coming to this point, what happens here? Tell me which hydrogen, which carbon has a sp2 hybridization. Just we have to calculate. This has sp2. This has sp2. Now this will have sp2 hybridization. sp2. Here also sp2. This one has sp. This one has sp. Next to this is compound same, na? So no need to explain it. So next one we have to explain like this. I will tell you. Here what happens? We can write like this also. C double bond O CH3 na. So what happens here? This is sp2. So if any carbon is attached to 1 pi bond, it undergoes, tell me, 1 pi bond means what? Double bond is there. If any carbon is attached with 1 pi bond, so it will undergo sp2 hybridization. If it is attached with 2 pi bonds, it will undergo sp hybridization. Now tell me it has 1 pi bond, that's why sp2 hybridization is there. So now tell me this carbon, how many pi bonds will be there? 2 pi bonds. 2 pi bonds means sp hybridization. Next, coming to the next carbon, what happens? This also undergoes sp hybridization. This will undergo sp2 hybridization carbon. You are getting my point. Now tell me number of sp2 carbons and pi bonds number. sp2 carbons, tell me, 1 2 3 4 5 6. 6 are there? 6 will be sp2 carbons. Pi bonds, tell me, pi bonds how many are there? 1. Here 2 3 4 5 6. 6 are there na? sp2 carbons how many? Carefully read. 1 2 3. This one also undergo sp2. Total 7 sp2 carbons. Okay, next, coming to this point, what happens here? Here CH3 is there, though it has single bond, so it has undergoes sp3 hybridization. It will, double bond is there, 1 pi bond is attached, so that's why it undergoes sp2 carbon. Here CH is there, already 1 pi bond is there. This is sigma bond, we don't consider it as. It has sigma pi bond. 1 pi bond means what? sp2 carbons. It has 2 pi bonds. 2 pi bonds means what? sp hybridization. Now coming to this point, it also has what? sp3. Oh, tell me here what happens. Sir, this carbon is attached to 1 pi bond. Okay, 1 pi bond means sp2 hybridization. Okay, take care. What happened here to this? It is also attached to double bond. It is also attached to double bond. So one carbon has 2 double bonds. It means what? Double bond attached means what? sp2 hybridization. Don't consider like this. If double bond is attached to carbon, it will definitely not a sp2 hybridization. Touch. I am telling you that if carbon is attached to 1 pi bond, it is sp2 hybridization. If carbon is attached to 2 pi bonds, it must and should be sp hybridization. Tell me how many pi bonds attached to this carbon? 2 pi bonds, you know. So this one and this one, 2 pi bonds will be there. If 2 pi bonds are attached, what happens? So definitely it has sp hybridization. Next, coming to this one, CH2 group, it will undergo sp2 hybridization. Okay, this is the manner, this is the way of find out hybridization. Next, last one is, so listen here, what happens here? Tell me here what happens. We are going there. Is there any hybridization is there? Conjugation is there? Tell me here what happens going there. So this undergoes hybridization. It means resonance structures will be there. Coming to this point, what happens? So how many bonds are there? Only 3 bonds for carbon atom. Only 3 bonds in Mars. Is there any conjugation is there? Conjugation? No. How can conjugation will be there? No conjugation. It means what? sp2 hybridized carbon. So 3 sigma bonds will be there. You have to observe it. 3 sigma bonds. 3 sigma bonds will be there. So it has to be sp2 hybridized carbon. Okay. Next, coming to this point, what happens? Tell me this one. Negative charge. These are, this one and this one is undergoing conjugation. How? It like this. It will undergoes like this. So this much part is undergoing conjugation. So that's why. So this is sp3 carbon. You are getting my point. sp3 carbon it is. It is sp3 carbon. Next, it will undergoes sp2. It is also undergoes sp2. It will undergoes sp2 hybridization. You are getting my point. Thank you. Next one. So okay guys. Okay friends. Next we are going to discuss about. So we have to find out number of pure and hybrid orbitals. Number of pure and hybrid orbitals. How can you start it? Okay, so we have to go through this one. So what happens here? Number of pure and hybrid orbitals means hybrid orbitals formula, main formula is hybrid orbitals 2 into number of sp carbons, number of sp carbon atoms. If sp2 hybrid is there, sp2 means s1 pr2, so 3 into n number of sp2 carbons. If sp3 is there, 1s 3p, so total 4 is there, 4 into n number of sp3 carbons. We have to go through that one. So coming to the pure orbital, if you want pure orbitals, simply number of hydrogens whatever it may be in the molecule plus 2 into number of pi bonds. What are you already I told you how to find out number of pi bonds will be there. I told you that you have to find out number of pi bonds. We have to multiply with the 2 and add with the number of hydrogen whatever it may present in the molecule. So what happened? This is ethene. Ethene means what? Ethene C2H4. C2H4 means you have to find out hybrid orbitals. HO number of hybrid orbitals. Formula, it will undergoes sp2 carbon, it will undergoes sp2 carbon. Okay, 2 into, you know that sp2 for sp2 3 into, you have to multiply with 3. Okay, 3 into how many number of sp2 carbons are there? 2. So that's why here 6 we have to get. Here we have to get 6. So next one, coming to this one, is it correct or wrong? sp2 means how? sp2 means, is it correct? Okay, next one, pure orbitals. Pure orbitals formula, number of hydrogens. First of all we have to add number of hydrogens. How many are there? 4 hydrogens are there. Plus next one, coming to this point, 2 into number of pi bonds. How many pi bonds are there? 1 pi bond is there. So that's why we have to multiply one pi bond with 1. How can you get 6? What is the ratio for hybrid orbitals is to pure orbitals? Tell me. Hybrid orbitals is to pure orbitals. 6 is to 6. It means 1 is to 1 is there. Next, coming to this next point, ethane molecule. Ethane molecule. Ethane means what? HC triple bond CH is there. Now tell me, this has sp carbon, this has sp carbon. If sp carbon is there, now tell me hybrid orbitals formula. Sp is there, sp for this one, 2 into number of, is there any sp2, sp3? So neglect that value. Coming to the sp carbon. Sp carbon means sp is there. So what is the formula? 2 into, we have to must add 2. So 2 into, how many number of carbons are there? 2 is equal to how much? 4. So coming to the pure orbitals. Pure orbitals form number of hydrogens 2 is there. 2 into, sorry, 2 plus pi bonds. How many are there? Pi bonds, not sigma bonds. Listen bro, here pi bonds, 1 sigma bond is there, remaining are pi bonds. 1 sigma bond means remaining how many are there? 2 are there. 2 pi bonds will be there. So 2 into 2, total how much? 4 plus 2, 6 is there. So hybrid orbitals is 2, pure orbital, what is the ratio? 2 is to 3. Next, coming to this benzene. Okay, benzene, you know benzene, you know that. So this is the structure, benzene. This is the structure, this is the structure, you know. So now tell me hybrid orbitals. Hybrid orbitals, tell me hybrid orbitals. Each and every carbon undergoes sp2 carbon. Already told you sp2 carbon means 3 into sp2. Don't see there. So sp2 means 1, 1s, 1, 2p2, total how many? 3 are there. 3 into number of carbons in benzene, you know, 6 is there, 6. Next, how much it is? 18. Okay, I understand. Next, coming to the pure orbitals. Pure orbitals formula, Se6H6 in benzene rings. H6 means what? How many hydrogens are there? 6 hydrogens are there. 6 hydrogens. 6 hydrogen means, now tell me here, how many pi bonds are there? 2 into pi bonds, how many are there in benzene ring? 1, 2, 3. 3 are there. So that's why 3 bonds will be there. Tell me total 12 is there. You have to ratio, find out ratio for them. How? 18 is to 12. How much? Shall I tell? 3 6 are 3 4s are 3 2 3s are 2 2s are 3 is to 2. Okay, so we will meet for next video, friends. Okay, don't what I am telling you. Okay, sorry for that. So we will meet next video with a deep section. So you have to continue this. I will continue this one in next later. Thank you. Okay, bye friends.